The Radio Waymo Breakfast.
Live from the New Scientist Labs,
Janine Young.
newscientist.com.
Melbourne City, of course. Janine Young, hello to you.
Good morning, Waymo.
Good morning. First story up this morning, looking forward to this one. Flight of the living dead. Birds. How did the birds that we see today evolve from the dinosauric birds, with the big talons on the wings and the leather-type wings and the massive wingspans? How did we come to have the birds that we have now?
Yeah, put it this way, Tyrannosaurus rex ain't no bird. It's one of those sorts of things that you have to sort of work out which type of dinosaur you're talking about the birds being descended from. Now, they think it was probably the theropods. Now, I'm no dinosaur person. I know lots of people out there love them, but I really don't, I've got to say. However, these theropods were a suborder of dinosaurs, and they contained the species that Archaeopteryx. Most people would know about Archaeopteryx. It had the wings of a bird, and it had all the teeth and the like of a dinosaur. It was contained within that, but it didn't have the collarbones and the like. So there were differences, and there was for a long time a lot of debate as to whether or not birds were in fact descended from dinosaurs. And it's one of those sorts of things that you sort of, as a person who doesn't understand dinosaurs and evolution and all of that, there was a lot of argument about it. However, things like feathers are thought to have begun evolving even before birds started developing. It's a really strange sort of thing. They think it might initially have been for display. It could be that they were also for insulation, for warmth. And over time, birds possibly hopped from tree to tree, and they found the feathers gave them just a little bit more lift, and so they kept doing it and the like. There's a whole bunch of different things here that you think to yourself, well, how does something evolve over, say, 245 million years?
Yeah.
And we are talking on that kind of scale. It's extraordinary.
And it's like let's say it is that sort of birds hopping from tree to tree. Well, then how does the right down to the molecular structure of the bird know that the bird is trying to do that, so I better grow some feathers? The mind boggles.
Well, I suppose that then comes down to natural selection, the theory that Charles Darwin put forward in the 1800s. The whole idea is that the most successful at the thing that the animal is trying to do is the one that's going to pass on its genes,
right,
to be able to then have the next generation do it again. You get some random mutations, and some animal becomes even better at it. And that's the one that's most successful, passes its genes on and the like.
Yeah.
That's the basic idea of natural selection. But to get from something that's sort of hopping from trees to flying is an incredible stretch. There are some that believe that they could have had fight feathers on both legs and arms, which means they couldn't have run along the ground. Of course, as in all scientific debates, there are those that go, oh, don't be stupid. Of course it wasn't like that. But you're dealing with creatures from, 145 to 200 million years ago, and you're dealing with the fossil record, which means that you don't always know exactly what's going on. It's very difficult to try and work things out. There's a bunch of dinosaurs' bones, early birds, that were discovered in China in the 1990s that have actually shed some light on all of this. But even so, you're dealing with the Cretaceous period, for example. So between 65 and 100 million years ago, there was a bewildering variety of birds, apparently, but there was only the modern birds that survived the asteroid strike that killed off the dinosaurs 65 million years ago. And it was because they think these were slightly smaller. You can have more offspring, you have a shorter reproductive cycle, you regenerate faster. They're able to fly away, to be able to move to different areas that didn't have the impact. Big dinosaurs couldn't do that. So the fact that they actually evolved at all is incredible, but apparently birds have really different types of brains than actual other dinosaurs did. They have something called a WULST, W-U-L-S-T,
right,
part of the brain that is, it makes birds adaptable, and it allows them to become really successful because it is effectively their intelligence. So they had a really decent-sized WULST, and they think that might have been why birds were smart enough to be able to then adapt, get up, fly away, go and find other habitats. And that's how and why these birds were able to survive when nothing else did.
Interesting. Well, staying with animals, onto the second story. Could solar-powered animals help feed the world?
Yeah, this sounds like one of those horrible sci-fi things that someone might have thought of.
Put the animals to work.
Yes, let them earn their keep as opposed to just being.
Yeah.
It is a question that seems a little far-fetched, but the idea of perhaps photosynthetic fish means that you wouldn't need to feed them in the way you do now, because they're quite hungry for other fish, which means that they start getting into fish stocks, and it has actually quite serious impacts on the environment to be able to farm fish. So the whole idea of being able to put photosynthetic bacteria or genes into a fish is a really appealing one. However, it's not that simple. Plants evolved by taking up cyanobacteria. They were little bugs that were able to photosynthesize on their own. They took them up and made them work, basically. They became symbionts, and over time it evolved into a new creature that was able to produce that kind of energy. What that required was changes to the internal structure of what was originally the plant, changes to the way that those genes are expressed. You need to pick up the ability to be able to control the cyanobacteria, now the chloroplasts. You need a lot of changes. You need to be out in the sun all the time. And you think to yourself, oh, that's not so bad. But think about being at the beach. You can have too much of a good thing.
Oh, bacon.
And I have incredibly pale skin, so I burn at the drop of a hat.
Yeah.
And the same thing would apply to a lot of animals if you tried it. For example, salamanders, the particular type of salamander, does take algae up during its egg formation stage, but as an adult, they don't retain it. And for them, if they needed to stay out in the sun to be able to provide photosynthesis, to be able to photosynthesize, to be able to provide their food, then that's a clear risk because it exposes them to all the predators they're trying to stay away from. So certainly for that mammal, it won't, or that creature, it won't work. It's no accident that a lot of the creatures that do use photosynthetic bacteria, so sponges, anemones, hydra, bivalve, are already out in the sun, and they often have very translucent skin, which means that the sunlight can get through. It's also no accident that most of those are in fact all of them at the moment, are in water, because that means that it can actually dissipate some of that heat and some of the high energy that comes from the sun. It's a really tricky process. In theory, yes, you could generate a fish that does have photosynthetic capabilities, but there's a lot of other things that need to go on to make it work properly.
But can we hook them up to the national grid?
Not yet. No, electric fish might be your best option there. At the moment, they're not going to be able to do the job, and even if they could, it's very possible that there will be no more benefits, no more efficiencies than you're currently getting. And the effort that it would take would be disproportionate to the outcomes. So while a photosynthetic fish looks like a really good idea, it mightn't work quite as well as we might hope.
Because I the whole Flintstones thing is quite appealing, where you get the animals to do all the basic tasks.
Wasn't that the pre-industrial revolution thing?
Yeah, but it's back to
We've been there and done that.
It's Back to the Future. There's an animal under the sink that's the incinerator, the garbage disposal.
Oh, yeah. You've got the little hamster running in your computer.
That's right. You've got the bird that can play the records, with the beak.
I liked him. He was really cool.
Hey, thanks very much, Janine. We'll catch you on newscientist.com. And, of course, those stories in the New Scientist magazine coming out next week. See ya.
See ya.